A very good afternoon. This is 3 o'clock in the afternoon. So we are going to study today the Turing machine. I must congratulate you, all of you, on this topic, in fact, because the ultimate machine or ultimate theory of computation, which can do all the jobs which is done by finite automata, the PDA or LBA, which is yet to be studied, can all be done by Turing machine. And Turing machine has very interesting properties, though very simple. Okay, you will find very little difference between finite automata and Turing machine. The only difference is in Turing machine you can write also, and the head can move left and right both. Okay, so let us proceed to study what is there in Turing machine. Now before we go to the Turing machine, I like to tell you one more thing. The Turing machine is a language recognizer and Turing machine is a computer also. We have never studied how to make 4 plus 4 8, how to make 5 plus 5 10, how to make 4 plus 6 10. We have never studied this computation yet. In none of the machines we have studied, but Turing machine has the capability of arithmetic computations, unlike all the three remaining things, including linear bounded automata. In addition, it is a language recognizing tool. In fact, Turing machine is an algorithm, and the Turing machine is ultimate computer in the world. It is said that there is no machine more powerful than Turing machine. The supercomputer at NASA is less powerful than Turing machine. All the computers of the world put together, and if they're all the memories combined, it will be still far less powerful than Turing machine. And that is why I must congratulate you on this occasion that you are going to study a very super computer, though very simple. Okay, so let us proceed. Turing machine is because of the Alan Turing. Alan Turing was mathematician. He was professor in Princeton. And interesting thing is, in the British time, his parents worked over here, and their parents or mother moved to England just before the birth of the Alan Turing. Okay, so there is a connection with India of Alan Turing. Highest award given by the computer industry for the highest research every year is called Turing Award. You may search on the web what is the Turing Award. Okay, so you might have heard the Turing test also, maybe. So Alan Turing was one of the founding father of the computer science, and the model given by him is called Turing machine, which we are going to study today. Is a inspiration or premonition of the electronic computers. In fact, computers came after say 1954-55, including the COBOL language and the Fortran language, starting with that. But the Turing introduced this model in 1936. Okay, Turing died in fact in 1954. So he invented the Turing test for testing whether a machine is really having the artificial intelligence or not. It is called Turing test. And the legacy, as he mentioned, is the Turing Award, which is awarded to eminent research in the computer science. Then there is a sudden branching to a new topic. Church-Turing thesis. What is this thesis? This thesis says that the ultimate model of the computer is the Turing model. Anything which is solvable, any problem which is solvable should have an algorithm. You cannot solve a problem without any algorithm. And whatever the computation is required by that model, that ultimately turns out to be a Turing model. Okay, so it says, the in simple words, the Church-Turing thesis says that whatever the model for computation you create, that this is the new model for computation, for language recognition, you will find ultimately it turns out to be a Turing machine. Okay, now what else? There are many other models are there, okay, like RAM model, like RAS model, which you will study somewhere in the advances in algorithms, or what is called DA, design and analysis of algorithm. All those models ultimately they turn out to be the Turing machine. So Turing machine is the ultimate model. What is this a Turing machine? We cannot go to market and buy a Turing machine. We want a Turing machine. It's a model, okay, and that model exists on the paper, okay, in the form of pen and pencil and paper, nothing more than that. So this model is like this. There is an infinite tape, like the finite automata. It is having finite control like the finite automata. But unlike the finite automata, it is a read and write head. Finite automata is read. Unlike the finite automata, it can move right and left. The head can move to right also, head can move to left also. Then for every machine we defined a model, okay, that is model of the machine. M stands for the machine. So the Turing machine is having finite set of the states, okay, the finite the set of states, then sigma, tape alphabet, what you write on the tape, rather input alphabet. This is input alphabet, A, L, P, H, A, input alphabet, okay. Then gamma is the tape alphabet. How this tape alphabet is different? Because on the tape there are blank symbols also. Blank symbols are not in input, and tape alphabet include one special symbol, this one, which is the end marker in the left hand side, that also is part of the tape alphabet. And therefore tape alphabet is nothing but the input alphabet, which can also be written on the tape, and a blank and the left end marker. Clear? And transition function, of course, and then starting state, of course, and there is a halting state. Okay, we never say accepting or rejecting. Our computer halts. Okay, so our processing has been halted. So here there is a halt state, which is not the, it is not final, but machine has done the computation. That means it is halted. Okay, so transition function, once there is a halting state, then there cannot be further state. So transition will take place if the current state is any state but not halting state. Q minus H means a state which is not halting state, and takes the alphabet on the tape, then goes to a new state, okay, and then write something on the tape, and then read head moves to left or right. Okay, read right head moves to left or move to right. So remember this. Let us recall what is doing. It is pointing certain position. After reading the character based on the current state, it will write something in the position, then head moves to right or it moves to left. Once it moves to right or left, there is a certain symbol. Based on that symbol, it will change to a state, and after changing, the read write head will move either to the right. Each such movement is called a transition. Okay, and therefore delta is called transition function. Okay, it is a partial function. You know, in mathematics there are functions which is mapping, but partial function do not have mapping necessarily always. Okay, so how you recognize the language acceptability? That language accepted is nothing but consists all the string w such that w belong to the input alphabet. Okay, and there is a current state, beginning state q0. The Turing machine is in a state q0, and on the tape there is a w, and then there will be moves. This symbol stands for the moves, and star means arbitrary number of moves. After making n number of moves, okay, there is a alpha on the tape. Alpha consists the symbols. There is no concept of terminal, non-terminals over here. Okay, it is simply the symbols. Then it is in a certain state, and there are certain symbols on the tape. That means certain symbols before the head and certain symbol after the head. P stands for the current state, and current state is the head position. So after head position there is something, before head position there is something. Okay, and this P state is a halting state. Once it has reached to halting state, then we say it is the machine has done the computation. And this alpha and beta are nothing but strings from the gamma. These are strings from the gamma. That means these are input alphabet and blanks. Okay, so now let us proceed. Next, it is clear so far. So Turing machine has infinite amount of memory. Tape is infinite. As I mentioned, it came in 1936 by a paper of Turing machine. Name of paper is Decision Problems. You may search on the net. Then Turing machine versus human beings, if you compare, the Turing machine model is based on the human problem solving process. How we solve the problem, we have a certain number on the paper, we perform calculation, then we say equal to this, equal to this, equal to this. There are steps. Turing machine also act on the original value, and then based on that it performs the computation. So it is based on the concept how humans solve the problem. Therefore Turing machine is more close to human way of solving problem. So we do this in our mental process. When we are solving mental process, through the mental process, I for example I write 5 plus 2 I am adding. So in my mind there is a 5 plus 2 7. So that 7, the value is there, and the mental state says that I have done this much calculation. So there is some mental state. The mental state is like a state of Turing machine. That mental state changes as you go from step to next step. So Turing machine also changes states as you go from one smaller computation to next computation. Okay, the Turing machine has correspondingly the paper on which it is writing. Where we are writing in mind. Read, write, head. Okay, pencil point to the symbol on the paper. Okay, once you are solving problem on the paper, where the pencil is pointing to the current point of computation. Here also the head is pointing to current symbol on the tape. Okay, and there is a state. That state corresponds to the state of the mind. Okay, so far all right. So this is the analogy of the Turing machine versus the human mind. Turing machine functions more like human machine. This problem we have solved. Language recognition A and BN using what? Using PDA, and through context free grammar we generated these strings. There is another problem. We put one more A and B and Cn. Now A and B and Cn you cannot solve by the PDA, because in PDA you will push A, and as many times B comes, so many A's you will be popping. But in this case, if you push A and after that once you read B, then as you have completed the reading B, you would have popped down all the A's, so you do not know how many C's are there. You cannot guarantee that C is equal to B. So you will find the second problem cannot be solved by the PDA, but the second problem can be solved by Turing machine. Then another term we would like to know is the power of Turing machine. The power of Turing machine is the problem solving capability. It is not the speed. Okay, if somebody can say that I can do the integration using pen and pencil. Okay, so we do not ask at what speed you can do. Speed is a question of examination, but whether you know or not. So problem solution is nothing but what problem solving capability is having, and it is not about the speed at which it is doing. Remember this, power of problem solution is not the speed but what problems can be solved. Okay, now let us go to the Turing machine. Okay, further, okay, so Turing machine are automata because there are transitions. They are very simple, and computation can be represented using the Turing machine. Acceptability by the Turing machine. How the Turing machine accepts? That you already mentioned. Acceptability means language acceptability. We are talking of acceptability in the form of language. So language is nothing but consists all the string W such that W belong to sigma star. Okay, and this sign of and what end? Beginning your state Q0 and W is on the tape and Q0 is pointing to first symbol of W. W is written after Q0 means the Q0 that is head is pointing to first symbol of W. And there are a number of moves are there so that finally you reach to this configuration, and the Y is a halting state. The same definition we have given earlier also. It is just a repetition. Okay, so let us try to do something useful. We would like to erase the entire tape. What is that? We would like to erase the memory of the computer. How much? All the memory in which we have A, as many times of A are written, all these A would like to erase. Okay, so how to proceed? So what we do is first A is written by blank. It is means written by blank. Second A also is replaced by blank. Third A also is replaced by blank. Third A is also replaced by blank. We do this as long as A is there. Okay. So here are the specifications. Very simple problem. So this is Turing machine. Q is, there are only two states, Q0, Q1. There is only one alphabet A, and tape alphabet consists of small a, blank symbol and left end marker. Starting state is a Q0. Okay. So, and Q1 is a halting state. The moment you reach to Q1, machine will be halted. So let us have the transition function. So once you are at Q0, you find input A. It will remain state Q0. Write blank in the position of A and moves to right. This is given by this loop. Okay, you are having symbol A. Let's have a different color. You are having symbol A. Okay, you are having symbol A. You are having state Q0. You are having state Q0. Then you write blank in place of A. You write blank in place of A. You are writing blank in place of A. And then you move to right. So that you go to next position. You go to right. And what is next state? Next state is same as original Q0. Next state is same as original. You come back to the original state. So this loop is replacing A by blank, A by blank, A by blank, and so on, moving right. So once it is moving right, ultimately it will find a blank space. Okay. Ultimately it will find, once A is over, it will find a blank. So that blank The moment it finds blank, then it has to write something. We'll say we don't want to write anything. If you don't want to write anything, then write the blank. So writing a blank on the blank means not writing anything. So blank is written by blank and head moves to left. Head moves to left. And the Turing machine has halted. So this is shown by, once it is a Q0, you find a blank, Then after that you go to state Q1, write a blank and head moves to left hand side and halt it. So these two instructions, instruction 1 and instruction 2, these two instructions of the algorithm erase the entire tape. First instruction is looped, again performed, and second instruction is halting instruction. So this is the algorithm in which there are two instructions and those instructions are erasing the memory. Okay, and progressively, what W is initially this one, Q0, all 4 A's are there. First Q0, it is encountering A, so A is replaced by blank, head moves to right, so head will be moving to next, pointing to next one. Next A is written by blank, head point to next A. Next A is again converted to blank, head moves to next one, next A. The next A also is converted to blank, the head moves now to, it points to blank. 4 blank हो गया, 4 A का जगह, then it points to the blank. Once the head points to blank, then it goes to state Q1 and moves to left, and because it moved to left, so it has come one position left hand side, one blank is this side, so you halt it. So basically the input tape consists the left end marker, the symbols x1, x2, etc., and this. There are certain symbols to the left of the tape, which you may call as alpha. There are symbols left of the head, okay, on the tape, and there are other symbols which are including the head symbol, okay, to the right hand side. This we call as a beta, and head is pointing to where? Head is pointing to first symbol of the beta. So we represent this as alpha, then Q, and there is a beta. No, this is not beta. Let us erase, this is beta. Okay, so this is beta. So this configuration, okay, we call alpha Q beta is a configuration. So next we define configuration of a Turing machine consists lot of symbols, then other symbols which you call as alpha, which you call as a beta, and the head position is in the beginning. Head position is beginning. So the current state is this one, symbol on the tape, all this, the head is pointing to QI. So when you write physically, there, if the head is pointing to 0, we will be writing symbol, the state, that means head is pointing to this 0, and these are symbols right hand side. Head points to first symbol in the right hand side. So you call this as a configuration. This is a configuration. So we defined what is the meaning of a configuration. Okay. So again here there is a, if there is a transition like this, okay, if there is a transition like this, that means what? The B has been replaced by C. B has been replaced by C. Head moves to left, and it goes from the state QI to state QJ. Okay, so if it is like this, Q U A Q I B V, what will happen? Because of mu, because of the bow, the B will be replaced. B will be replaced by C, so B becomes a C. Okay, and head has moved to the left. Head has moved to the left, so head will be moving. Earlier head was pointing to B, head will be pointing to A. So the head is pointing to A now. Immediate A is after the head, and state has changed from Qi to Qj, so we indicate like this. Similarly, if there is a right movement, then head which was pointing to B, it moves to right, so therefore it will be moving to V. And because the B is modified, B is modified as a C, so the B which was here, that B becomes a C here. Okay, so this B becomes a C. So this is how we can show the transitions. Okay, so now we have one more problem. Okay, so what we want to do is we want to understand this language using the Turing machine, that whether the string is having equal number of A's followed to equal number of B's. So here there is a description. What I will do is I'll explain, we'll see manually, we'll discuss. So I add a new page after this. Okay, so let us see. I'm having A, B, B and B. And beginning, the read write head is pointing to what? Pointing to this position. What we'll do, we convert small a to x. फर्स्ट इस a को स्मॉल a में कन्वर्ट कर दिया, आगे बढ़िए. फिर a है तो a को a ही रहने दें, फिर अगला a है, अगला a को भी a ही रहने दीजिए. ओके, एंड नेक्स्ट इज गोइंग टू बी b, so convert the b to y. The moment you convert b to y, we come back. Okay, we come back from this point. So what will happen? This b will remain as it is, this b will remain as it is. The moment we come to the left, again go to left, the moment we find the x, then write the x as it is. We read the x, we write the x. The moment x is there, we found the x and we write back x. After that we are having a. Okay, so this convert a to x, only one a. Other a, let it as it is, scan. उसके बाद में y है, scan the y as it is. Go further, and if the b is there, convert b into y. Convert b into y. So make it a is something else. Okay, so convert b into y, and after this we turn to left. That means this b remain as it is. Okay, this b remain as it is. The moment we converted one y, we return back. And after this, once you go, the moment x is there, we go back. The moment we find the x, we turn back to right hand side direction. So we turn back to the right hand side direction. That means we are having x as it is, second x as it is. Okay, and then when you find the a, convert only one a to x. Then scan through the y. Scan through the y. What is the meaning of scan through y? If the y is there, read y, write y, go to right hand side. Read y, write the y, go to right hand side. And when you find the b, convert b into y. Okay, So you will find every time one A was converted, one B was converted, next A was converted into Y, next B was converted to Y, next A was converted into X, next B was converted into Y. So as many times A is converted into X, so many times B is converted into Y. And the moment this Y is converted, we go back over here. And the moment we find the X, from the X we turn back. And we search for what? We search for A. We didn't get the A. Then scan through, go further, scan through Y. Y is not found. But ultimately, there is a blank available because in the tape, all the other symbols are blank. Are you getting? All the symbols other than what we have kept as an input are blank. To this blank we are reaching first. Earlier we turned back from here, we turned back from here, we turned back from here. This time we scan the Y and we further go, we will find there is a blank. Once there is a blank is found, then we declare and what we do? We halt. Okay, we have halted. Job is done. We have recognized that number of A is number equal to B, and it will work irrespective of whatever the magnitude is there. Okay, so there are 4 states. Alphabet is AB, left, tape alphabet left and marker. What is input? That also is on the tape, and once they are on the tape, these are tape alphabet also. X, Y we have written are tape alphabet. B is existing in the tape in blank position. Start state Q0, halting state Q4 and Q0 also. Once there is no input, then directly we accept. So here is the design. Here are the transitions we have mentioned based on what I discussed. Key, when it is a Q0 and input A, you remain in the Q1 and write X and go to right side. Okay, go to Q1. So once you have in Q0, input is A, write A by X, go to right side. And once you go to Q1, in the Q1 skip all the A. Every A you read and write back A and go to right hand side. Chalte rahiye, chalte rahiye. Once you finish all the A, you will find B. Convert B into Y and turn to left. Once you are turning to left, you will find what? You will find A's. Okay. So those A you keep as it is. A is there, read A right, go to left. Once you proceed further, ultimately you will find you will come to X. The moment X is there, read X, write X, then go to right hand side. And once you go to right, you will find next A. Next A is there, replace X by X, A by X, go to right hand side. Then you will find number of A's. Read A and write A, go to right hand side. After that you will find Y, which previously you created. Okay. So if Y is there, skip the Y, go to right hand side. Then you will find those B's which are yet not converted into Y. So convert one B into Y, go to left hand side. After you come to left, turn to left, you will find what? You will find more Y's, previous Y's. Skip Y's, that means Y read, Y write, come to left. Further you come to left, you will find A. So every A you skip, read A, write A, come to left. Further if you go, you will find X is there, read X, write X. So carry on like this process. Finally, what happens? Finally, you will find that you have converted all X, A into X, converted all B into Y. Okay. So once you further come later on, you will find there is no A left. Okay. When A left is not there, then what will do? Okay. So all the A's have been converted into, but the moment X is there, you go to right hand side, so you will find all the Y. So read y and write y, skip through the y. Then all the remaining y's you just skip. Read y, write y. Okay. If you further go, you will find a blank. If there is a blank, read blank, write blank, then come to left. And this is the state 4, which is halting state. What is meaning of this arrow? In the beginning itself, if you are having blank, because if there is a 0, n is greater or equal to 0. In the beginning, there is no a and no b. Then what will be there? There will be blank. So if it is blank, write the blank, read the blank, write blank, go to left and go to 4. So that means if there is nothing in the tape, in the beginning it's blank tape, then also language is accepted because n is greater or equal to 0. So you come over here, you reach to 4. Okay. So what it explains is nothing but all these transitions, and there are 4 states. Okay. So 5 states by which you can recognize this. Okay, so all the moves of this we have explained, that how it happens one by one. So if you try to find out the number of steps incurred, length of input is n. So there are n by 2 forward and n by 2 in the backward. In each to and fro round, there is n. Half n by 2 forward, n by 2 backward. So total is, every time you perform operation 1 iteration, there are n. Since each trip 2 symbols are marked, A is converted into X, B is converted into Y. Therefore, there will be total n by 2 number of trips, making total transitions n multiplied by n by 2, which is n square by 2. So time complexity is n square divided by 2, which is nothing but O n square, which is polynomial time complexity. So this Turing machine is programmed, and the number of instructions are equal to number of the different transitions, because every instruction performs something, and what is performed by the transitions. So we are having 1, 2, 3, 4, 5, 6, as many number of transitions are there, so many number of instructions are there. So this is a program, and once it is programmed, there is a complexity. So of what you call this machine, having a one tape called a standard Turing machine, we have used this, which recognizes A n, B n. You may think over, if it is A n, B n, C n, then what will happen? Okay, what you just think over that how to do this one. Once there are 3 things, A, N, B, and C, N. This can be done just by adding a single one more state. Okay, so I'm sure you must have rather enjoyed the Turing machine, because Turing machine is very interesting and is ultimate theory, and it is a super theory. It computes all the analysis, all the languages, anything what exists in the computer science is nothing but it is because of Turing machine. Okay, so happy reading of the Turing machine. Thanks for patience listening. I'm sure you might have gone through this in a single run, because matter is so interesting that we cannot afford to pause or have an interruption in between. So happy reading of the Turing machine.